But 4.4 systems of equations. I think that's supposed to say applications of systems of equations, but you know, spelling, that's pretty close. So writing systems. So remember, if you get standard form, you get totals. Usually this is the case. This is not, there's not really like a strict algorithm that you can use for these. But if you get, if you want to write them in standard form, usually we're going to end up with totals for two categories. You know, like tickets for children, tickets for adults. We'll see some with some chemical usages, and I don't know. Standard form is generally the way that we write them. Now, if we need to write them in slope-intercept form, they'll give us some type of rate of change. That's slope, right? Because that would be rate of change. And then some kind of starting or initial value, which is also the y-intercept. And remember, that's the whole idea with slope-intercept. With word problems, the slope is the rate of change. The y-intercept is the starting value or initial value, okay? So, if they give us those, the rate of change and the starting value, we'll just plan to write the equation in slope-intercept form. If they give us two totals, then we'll plan to write things in standard form, okay? And again, standard form, because I don't think we have this one down as well, or we don't deal with it as much, but it's ax plus by equals c, where the a, b, and c are numeric in some sort. And then slope-intercept form, just so we can see that again, y equals mx plus b, where m is the slope, and then the b, the plus b right here, is the y-intercept, or the starting value, okay? So here we got this one. Well, let's see, the sum of two numbers is 95. The difference of the two numbers is 63. What are the two numbers? Now, if you're going to do this with the system of equations, which I forget if the homework is going to force you to write this out, but see how they gave us two totals right here? This sum is 95. That's a total. And then this difference right here is 63. That's a total. So I would be looking to write these out as system with standard form, okay? So it says use x as the large number, y as a small number. So I'd look at the first equation with the sum. Does it have to be the first equation? It doesn't really matter. But I'm going to take my large number, and I'm going to take the small number, and the sum would indicate addition, and that sum is 95. So x plus y equals 95 right there. All right, so for the next equation, we want a difference. That's a subtraction. So I'm going to, and the difference, by the way, is positive. That's crucial to notice, because if it were negative, you have the small one minus the big one. This one's positive. It's going to equal the 63 right there, okay? So that means I got to take the big number and subtract from it the small number. So x minus y equals 63. This is set up perfectly for elimination or the addition method, which is the same thing. So I'm going to add these together because the coefficients of y already opposites. So I'd have 1x plus another x, that'd be 2 x's. The y zero out just as planned. And then 95 plus 63 is 158. I'll just divide both sides by 2 to find my, that'll be the big number. So x here is going to equal 79. Yeah, 79. Now that's the large number. And you can go back to one of the two equations right here to figure out the smaller number. I'll use the top one. I mean, it doesn't really matter which one you use because you'll get the same answer. But x plus y equals 95, and I'm going to replace the x with the 79 that we just found. Some of you, I think, at this point would have just did 95 minus 79, and that'd be fine too. But I'm going to use some principles of equality because they're just so fun. So minus the 79er, that's going to zero that out. That'll give us the y directly, so 16 it looks like. So what are the two numbers? We don't really need an ordered pair on this one. The two numbers, the x value, the large number is 79, small number is 16. That's it. It's not negative, by the way. It's just, there we go. I forgot. I should check. 79 minus 16 needs to equal 63, and it does. Okay, and then 79 plus 16 is 95. Yeah, we already checked that one. So I'm just pointing out that we should check off both of these in the end to make sure that it will give us a true statement when we use these two values, because we had really two conditions, and that's not too bad to check. All right, for this one, we got the sum of two numbers is 70. If the larger number is 52 more than the other, what are the two numbers? So we're going to write two equations for this one, starting with the first condition that they gave us, which is the sum of the two numbers is 70. So we're going to take x, the large number, and y, the small number, the sum is addition, and we should get 70 out of that. The second condition is if the larger number is 52 more than the other. So the large number, x, it should be the same as the small number, but 52 more than that. So we end up with these two equations, and this then becomes, especially from the purple equation right here, it's going to be easier, I suppose, to use substitution, because this x is y plus 52. So our red equation, instead of writing it as x plus y equals 70, I'm going to replace the x with that y plus 52. And then I have an equation with just one variable like this. So I would solve this by combining like terms. The two y's, I'll drop my 52. And then this still equals 70. But then solving this equation, subtract 52 from both sides. Drop my 2y, which now equals 18. And then, well, just divide both sides by 2. And that tells me the y value is 9. That's the smaller number, right? So if I took the small number here, y, which is 9 now, and I just added 52 to it, then I'd have the bigger number. Which, when I put that in there, it's going to give me 61. That's my large number, x. So we get the two numbers, though, 61 and 9. Now, we should check, right? So 61 plus 9, it needs to equal 70. It does. And then 9, the small number, plus 52 equals 61. So both conditions from the problem check off. Like this one. You are choosing between two different cell phone plans. The first plan charges a rate of 23 cents per minute. The second plan charges a monthly fee of $45.95 plus 10 cents per minute. How many minutes would you have to use in a month in order for the second plan to be preferable? And the second plan, because I kind of jacked this up earlier, but yeah, so the second plan is just kind of highlighting this one right here. That's our second plan. The first plan is just 23 cents per minute. That's our first plan, okay? So I want to compare these two. I'm going to look at the first plan first because it's the first plan, and it'd be 23 cents per minute. Now, be careful because some people would say it'd be 23 times M for minutes. It's 23 cents, so I'm going to use this as a decimal right here. And that would be equal to, I'm going to say C for cost on this one. So we can go ahead and define that, by the way, but M is going to be the number of minutes. And then the C value is going to be the cost of the plan, okay? And I'll use the same variables for the second plan as well, which says that it's $45.95, so that's what I'd start with, 95 cents. And then in addition to that, you'd be paying 10 cents. Now, again, this is where you got to be careful. It's not 10M. It's, I'm going to make that 0.10M. You could even say 0.1M, but this would be the final cost of the second plan. Now, both of these are informally slope-intercept form, because we do have a rate at 23 cents per minute and 10 cents per minute, and then the starting value. The starting cost of the first plan is $0. You only pay for the number of minutes you're going to be using. The second plan, though, did have an initial cost, some kind of monthly fee of $45.95. Okay, so we did see a slope and a y-intercept for both equations, but the question is, how many minutes would you have to use in a month in order for the second plan to be preferable? That's the blue one right here. What I would like to do here is find out where the two plans would cost the same. That is the substitution method for solving a system. So I'm going to look at the first equation, C equals 0.23M. But remember, the cost is the same. So the red C is the same as the blue C. So the blue cost, purposely replacing that with blue right there, because what does the blue C actually represent? It represents $45.95 plus 10 cents per minute, okay? And then this just becomes an equation that you solve for the minutes. Now again, this is just going to tell you when they're equal, right? So I'd say subtract 0.10 m from both sides. That'd be 0.13, 13 cents per minute for $45.95. And this can be interpreted, by the way. So we drop this, and this stuff's zeroed out. That's good. Last thing here, to figure out the minutes, divide both sides by 13 cents per minute, which is the difference in cost between the minutes of the plan. So that's number of minutes. Let's go to the calculator, which can do this much faster than I can by hand. I got a pretty ugly decimal, by the way, but 353.46 minutes. Now, again, this is this rounded, but this tells us when the plans are the same cost. But we want to know when the second plan will be, it says what did it say? The preferable. That indicates that it would be the cheaper of the two plans. Now, I know if I go below this amount of time that the first plan would be cheaper because of the $45.95, right? Like, let's say you choose to use the plan for 0 minutes. Well, I'd say 1 minute, okay? Then this one would be like 46 bucks. This other one up here, 23 cents. See the difference in cost? That's when we're below this value. So that means it'd have to go just beyond that in order to make the first plan, or the second plan rather, preferable. So I'd say, even though it doesn't round up right here, I'd have to go up a minute in order for this to work. So 354 minutes would make the second plan the most preferable or the cheapest. I'm not saying just to round up. I'm saying you got to analyze and look at the two plans, and you may have to do some calculation here. Like, what if you put 353 in here? Which one's cheaper? Well, I guess we could even check that. So 0.23 times 353. The first plan there is showing at $81.
Oh, so you just
19 cents, whereas the second plan, 45.95 plus 0.1 times
oh, so you just times the
3.
outcome.
Well, yeah, hold on a sec, hold on. So that'd be 81.25. So I can see that the second plan at 353 minutes is still more expensive. But the moment I go another minute, then this first plan will exceed the second plan amount, which would be that 354 minutes.
Oh,
Right, on this one, you spent $92 buying 15 books to donate to the local elementary school. Activity books cost $4 each, and storybooks cost $12 each. How many of each type of book did you purchase on this one? So we have two totals that were given to us. The first total that they give us was based strictly on just the amount. I guess it's an amount spent, right? You're buying these books. And then the second total they gave us was based on just the number of books. And remember, when we're looking at totals like we are here, both equations should be in standard form. Now, for me, you can use whatever letters you want. I'm going to use X and Y. Sometimes students will look or use A for activity books and maybe even S for storybooks, but S is kind of looking like 5s for me. So I'm going to say that X here will be my activity books. And then the Y can be my storybooks. And by the way, if you had these switched, you're going to get the same answers. It's just your X and Y's are going to switch. That's it. So how about money spent, right? Well, I know activity books are $4 each. So the money spent just on activity books would be the number of activity books, that's X, and then multiply that by 4, because the activity books were $4 each. On the other hand, how much was spent on storybooks? Well, Y is the number of storybooks. If you multiply that by 12, that would tell you how much was spent on storybooks. Add those two values together, and you should get the total amount spent, which is showing as 92 at the top there. Okay, well, what about the number of books? Well, you have activity books and storybooks. When you add those two values together, you should get 15 books. Okay, so this becomes a system of equations that we'll solve. And to me, it looks like elimination or addition will be the best strategy to use here. Okay, so I'm going to multiply this bottom equation here. I'm going to choose to eliminate the x's. So I'm going to multiply all the values by -4. And that way the coefficients of the x's will be opposites. So -4 times the 1x would be -4x's. -4 times +1y would be -4y's. And then negative 4 times 15 would be negative 60. The top equation wasn't touched. We didn't do anything with it. So it's just 4x plus 12y equals 92. But now that my coefficients of x are opposites, when I add those together, they will zero out as planned. Then the y's, I got 12y's plus negative 4y's, which would result in 8y's. I just do 12 minus 4. And then 92 plus negative 60, just 92 minus 60. That's going to be, looks like 32, looks like. Almost did subtraction. And then finally here, to solve for y, we'll just divide both sides by 8, which tell me y is the storybooks. 32 divided by 8 is 4. So just in labeling this, it's not just 4, it's 4 storybooks. But now that I have those storybooks, I need to figure out how many activity books there are as well. So I'm going to go back to the second equation here. Activity books plus storybooks should be 15. So right here I see that my y value now is now 4. So I really got x plus 4 equals 15. As an equation to solve this anyways, you just subtract 4 from both sides. I know, and I think most of you would have just said, well, 15 minus 4 is 11. And that would have been fine. But that's your x value right there, which is in activity books. 11 activity books. Now, those should be our two answers, right? 11 plus 4, that's going to be 15 books. That first condition is satisfied. The second one is the $92. So 4 times 11, that's 44. 12 times 4 is 48. 44 plus 48 is $92. That would have been $92 spent. And now we know for sure that we have the two correct answers for this. So going back to the beginning, if you had said X is storybooks, Y is activity books, the only thing that would have changed here is these letters. That's it. The admission fee at an amusement park is $1.50 for children, $5.20 for adults. On a certain day, 344 people enter the park, and the admission fees collected $1,108. How many children and how many adults were admitted? All right, so on this one, the question will kind of indicate or help you to at least form what the variables should be, right? So it says how many children, how many adults. Now, you could use X's and Y's, which I'm going to do, actually. So I'm going to say that on this one, I'm going to say that the X's are the children. Children admitted, if you want to be that specific. That's children. And then Y will be the adults that were admitted. Yeah, there we go. I think that's a good recovery. But Y is going to be the adults. Would it matter if you switched them? It wouldn't. Okay. Now that I got those defined, because there were the two things we're going to be looking for to solve this problem, the other thing we're going to look for is what format do we want these in. Now, I do see a rate, right? I see a rate for adults, $5.20 for adults, $1.50 for children. So maybe you could start thinking, hey, this is going to be in slope-intercept form. But notice right here that they gave us two totals as well. They got the people in the park, and then they gave us the total amount of money that's collected, okay? So the two forms that I'm going to be using are going to be standard form, okay? So I would first look at forming an equation to figure out how many people entered the park, okay? Adult or, oh man, there we go, that's better. So I'm going to write an equation just based on people, okay? And so I'd say you'd have children, that's the X, and then you'd have adults. Just add those two together, and that will tell you how many people entered the park. It says up here that it was 344 people. So that equals 344. So this total sets up very nicely with a standard form equation, okay? On the next equation, yeah, we are basing this on cost, right? So you have cost for children, that's X, and then you got cost for adults, which is Y. So on this one, we see that it's $1.50 for children. So I'm going to take the number of children, that's X in green there, and I'm going to multiply it by $1.50. Okay, so that's how much it costs for every child to come into the amusement park here. And then also we see that the adult cost is $5.20. So I'm going to take the number of adults, that's Y, which we don't know yet. I'm going to multiply that by $5.20. Okay, we'll just add these two together, And when I do add them together, I should get the total cost. I guess I put cost, maybe I should put fees or amount collected. But that's $1,108 right there. Now I have a system, which I can start to solve for one of the two values. And since the first equation is just x plus y, both coefficients are 1. It doesn't really matter which one we choose to eliminate. And yes, I am choosing elimination because both equations are in standard form, which means elimination is going to be the most convenient method at this point. All right, now that we have these two set up, I'm going to choose to eliminate the x's. I don't see that there's like an easier one to eliminate, other than the coefficient of the x in green here is just a smaller number. Okay, so I'm going to multiply here my purple equation by a negative 150. Okay, so this will give me a new equation, negative 1.50x, and then negative 1.50y, and then a negative 150 times 344, let's see. In my calculator, I got negative 516. So that's that new equation. Now, the green equation is still fine. I think this, kind of see if we can line these up a little bit. And now I can see that my coefficients of x, the x's are opposites, which means that I now look to combine those, adding them together to eliminate those x's, which it does. Got negative 150 plus 520, which is 370. That's how many y's I got. And then negative 516 plus 1,108. I got 592. And then to solve, I'll just divide both sides by the 370. Okay, now this is y, which is the number of adults that entered the amusement park. But what do we get on this? 160 exact. Oh, that's pretty good. So my final y value here is 160, which again, that's the y, so that's the number of adults. 160 adults, that'll be fine. Okay, but now that I have the number of adults, I'm going to use the purple equation from back in the beginning to figure out how many children entered the park as well. Some of you I know would just do 344 minus 160, and that's fine. I'm going to reset up the equation though, but instead of y, I'm going to use the value that we found, which is 160. See, and now, even at this point, you'll still have to subtract 160 from both sides. So either way, drop your x equals, that'll zero out for 184, looks like, children. So the last thing here is just to check 184 plus 160. That needs to give us 344. That's how many people enter the park. It does. And then to figure out how much money was brought in for the children, 184 times $1.50 per ticket is 276. And then for adults, right? So 520 times the number of adults, 160. That's 520. Typed that in wrong. 832. When I add the 832 to the 276, I get 1108. So that does check off for both conditions, which means that these two values that I got are indeed correct. And lots of problems to do. So Keegan invests $4,700 into different accounts. The first account paid 7%. The second account paid 10% in interest. At the end of the first year, he had earned $410 in interest. How much was in each account, I guess, at the beginning? So I'm going to look at just the initial investment to start out. And something else that I should acknowledge right here is that the two things we're looking for are the amount that was in each account before the interest was applied. So I'm going to say that X is the amount in the 7% account. And then the Y will be the dollars in the 10% account. Okay, and again, it doesn't matter if you get those switched. You don't even have to use X and Y for heaven's sake. You can use whatever variables you want to use. Now, the initial investment was the amount in the 7% account, and we would add that to the amount in the 10% account, and then that should equal the $4,700 right there, okay? So again, why is this in standard form? It's because it gave us a total, $4,700, and we see the other total right here is the amount in interest. So we should expect to see this equation in standard form, okay? So the second equation is based off of the interest earned. Okay, so the interest earned equation, we got the 7% account. So however much money was in that account, we would multiply by the amount earned, here 0.07. Make sure not to make that a 7 or 0.7. 0.7 is 70%, and 7 by itself would be 700%. That's very different, okay? Now the amount in the 10% account, you just multiply that by 10%, and that would tell us how much money was earned from that specific account. And when we add these two together, that tells us the total interest earned, which shows is $410. All right, now that we got this set up, it's pretty much like the last problem we just did with the amusement park. It's just, on this one, I'm going to choose to eliminate the y's strictly because last time I chose to eliminate the x's. That's it, okay? So the top equation there, I want my coefficient of y to be the opposite of my coefficient of y in purple. So that means I would have to multiply this equation by negative 0.10. So that'd be now a negative 0.10x minus 0.10y. And then negative 0.10 times 4,700 would be negative. See if I can fit this, negative 470. It's negative. And then, yeah, that second equation we didn't touch because we were just forcing the y's to match on this. And now we're ready to add these two together because the coefficients of y's, since that's what we chose to eliminate, they are now opposites. So I got negative 0.10x plus 0.07x, which is negative 0.03x's. The y's do zero out as planned. And then negative 470 plus, and that'd be plus 410 would be a negative 60 on that. Then I'll just divide both sides by the coefficient of x, negative 0.03. So that's phantom 1x. X now equals negative 60 divided by negative 0.03, and I got 2,000 right there. Now this was $2,000. That's the x, so that's $2,000 initially invested into the 7% account. As it showed up here when we first defined it. And then since there was 2,000 for the x, I'll use the top equation there. I'll replace the x with 2,000. Then if we add that to the 10% account, remember that was an initial investment of $4,700. So to solve this one, simply subtract 2,000 from both sides. So that zeroes out. I got y then equals $2,700. Again, specifically, that is in the 10% account. Okay, well, does this work? Well, 2,000 plus 2,700 is 4,700. That's true. Let's see if the rest works. So 0.07 times the x, which is 2,000. And if I add that to 10%, so 0.10 times the 2,700, when I push enter, I should get $410, which I do. So again, that's just a quick way to check, and I just use my calculator for that. But looks like that is correct on both accounts. All right, for this one, we got Nuts R Us sells cashews for $2 per pound and Brazil nuts for $1.50 per pound. How much of each type should be used to make a 50-pound mixture that sells for $1.80 per pound? Well, the first one I'd probably start with on this is that we need the two equations, right? And we know that the two things we're looking for, so I'm going to use x and y, though you could use different variables if you'd like. But it says how much of each type should be used. Well, that means we're looking at Brazil nuts and cashews, right? So I'll just say that X will be my cashews, and then Y can be Brazil nuts. Again, some students prefer to use C's and B's for this one. Doesn't matter. Again, I just like to use X's and Y's so I have some consistency there. But you don't have to. So first off, I'd be looking at the equation for the money, right? Because I know that if you take the number of cashews and just multiply it by $2, then we know how much of the mix came from the $2 mixture, right? From the $2 in cashews. That's per pound, by the way. And then it's $1.50 for the Brazil nuts, which I chose to be Y. If you add those together, then we should get the mixed value, which is $1.80 per pound, but there's 50 pounds of it. So we do actually have to solve that part. So in my calculator, I push 180 times the 50 pounds, and it looks like it gives me 90 right there, so 90. So now my equation shows, just for the money, 2x plus $1.50, y equals 90. Okay, so that's my first equation. Second equation is a little bit easier. It's based on the 50 pounds. So you take the cashews and the Brazil nuts, combine them, and you should get the 50 pounds right there, okay? So the last equation, the last problem, I eliminated the y's. Well, this one I'll just choose to eliminate the x's, but I will need more space. So this bottom equation here, I'm going to multiply all these values by -2. Okay, so that'll give me -2x minus 2y equals 50 times -2 is -100. And then we didn't really do anything with that top equation, did we? Okay, so this is what we're looking at, and just from this, we can see that the x's now will eliminate when I add them together. But what about the y's? 150y minus 2y's would be -0.50y. And then 90, you could say plus -100. Either way, it's going to be -10. Last thing here, just divide both sides by -0.50 or -0.5. And it looks like y then would end up being 20. Now, y is the Brazil nuts, and so that'd be pounds. Brazil nuts. Barely fit that in, but I think it still works. Well, if there's 20 pounds of Brazil nuts, just take those away from the 50 total pounds, and that'll tell you how many pounds of cashews there are. So that's 30. 30 pounds of cashews. All right, so let's check. Yeah, 30 plus 20, that's going to be the 50 pounds. How about 2 times the cashews? That'd be 2 times 30, so that's $60 from the cashews, plus 20 times 1.5, which is $30. And yeah, that'll end up being 90 right there. So both conditions are met, the number of pounds and then also the cost for these. This one tends to cause a lot of problems for students, and while it is only one problem, we still want to get it done, okay? So let's read it. A pharmacist needs 460 milliliters of 25% that stuff. I'm sorry, I'm not going to try to say it, okay? Yeah, thank you. I'm not going to try to say that word. But but it has only 15% and 95% that farbinidal stuff. Phenylbarbital. See how close I was? I don't feel better about myself, by the way. So find how many milliliters of each she should mix to get the desired solution. So the thing about this one is, like, I don't really see a lot of totals. I see the 640 milliliters, and that's nice. That's pretty. Which is a total, by the way, but I don't see any other totals. So it's like, am I going to be using, and yeah, we could use standard form for this milliliters right here. But what are we going to use? What format are we going to use for the other equation? Well, let's start with this equation first, because we can make an equation just out of this total right here, okay? The first thing I want to do is just to define my variables. And it says how many milliliters of each solution. Now, these are the two solutions that this pharmacist has, right? 15% and 95%. So I'm going to say the X, doesn't matter which one you say it is, but I'm going to say that it's the milliliters of the 15%, okay? Farbonyl, whatever it is, okay? And then the Y value can be the 95%er on this one. And again, it doesn't matter if you switch the letters, you could use different letters, but it has to be the 15% and 95%, okay? Specifically in milliliters. And we know that because that's the way that the question was worded. So, so we can say, look, take the number of milliliters. So again, this is just based on the milliliters right here. So we're writing an equation based on milliliters, and you got the 15% solution and the Y, the 95% solution. When you combine those, it told us you should get 640 milliliters, okay? There's one equation for us. Now, the only other information we're given on this problem is the percentages, okay? So the next equation will be based on the percentages of phenylbarbital. There we go. Thank you. See, I still don't feel good about myself for some reason. So on this one, we got the two solutions, right? We got the 15% solution and the Y, the 95% solution, okay? And yes, this one is going to actually end up in standard form, and here's why. Because I can figure out all the values based on the percentages. First, the 15%, right? So that's my X, so I would just multiply the X there by 15%. Phenobarbital, barbitolitol. Take that with some peto, and then you'll feel real good. And then the 95%, right? So that, again, I would just take the Y. That's how much of the 95% I have. And if I multiply that by the 95% right there, then I would have that amount of solution at that strength. I hope I'm getting that right. Now, if I add those together, I should get the final mixture, which is 25% of this much phenobarbital. Barbitol. There we go. All right, so what is the mixture? Well, the mixture is going to be 640 milliliters, right? But I want to know it's I want to say condensity, but I know that's the wrong word. I'll think of it. Give me a sec. Concentration, thank you. It's I'm working on it. 25%, right? You're going to make this 25%. So see how all these values are taken by the concentration, thank you again, multiplied by the amount. That was for the 15% concentration by the amount, okay? So that's the percentages. Maybe concentration would be the better word to use there. There we go, there's some concentration. On this problem, whatever you do, make sure you do actually multiply these two before you start to apply. In this case, I would apply the elimination method, okay? But you got to make sure you multiply the 0.25 and the 640. All right, now that we got this set up, I eliminated the X's on that last problem. So this one, I'll choose to eliminate the Y's. So this top equation will have to be changed a little bit, okay? So I'll have to multiply this by negative 0.95, each of the terms, okay? So that ends up being negative 0.95x minus 0.95y, and then 640 times negative 0.95. I got negative 608 on that. Okay, so the bottom equation wasn't touched. We still got that 0.15x plus 0.95y equals, oh yeah, so 0.25 times 640. There's going to be 160 on that. And now when I look to combine these, it will eliminate the y's for us, which was planned, okay? So when I add my x's there, how many x's do I end up with? A negative 0.80, and then negative 608 plus 160. I get negative 448 on that. So when I look to divide both sides by negative 0.80. To make that a phantom 1, I get x equals 560. So that's our x value, which is milliliters of that 15%. So milliliters of 15%, farba, whatever it is. Okay, and then now that I got that, remember the whole mixture is going to be a total of 640 milliliters. Just take away the 560, and this will tell us how much of the 95% we need. So 80. It'd be 80 milliliters of the 95%. Phenobarbital, there we go. All right, so let's see, 560 plus 80, that's 640, that checks off. How about 0.15 times 560? That's the concentration, that's 84, plus the 0.95 times 80. Enter, and I get 160, which is what we got from the concentrated, final concentrated mix. 640 times the percentage there, 160. So it checks off on both accounts. So rate equals, distance equals rate times time. You can have two objects. Actually, it's usually one object, like an airplane or a boat. Either it's going with the wind or against the wind. And for you physics nerds, yeah, I know it doesn't actually work like this, but this is a math class and we get to pretend things, okay? Like, for example, that you love math. Now, remember, you got these two equations. They're both derived from the same place, but distance is rate times time. I've heard students say it's dirt, whatever. Rate equals distance divided by time. It just is a manipulated form of this original equation, okay? So you may have to use this kind of format right here. If they tell you certain aspects of the two objects, whether it's distance, rate, or time, you kind of may have to set up an expression or formula yourself. And it's showing it as a table. You don't necessarily have to use a table. We'll see, okay? Like this one, an airplane travels 480 miles in 3 hours with the wind. The return trip against the wind takes 4 hours. What is the speed? The wind speed and the speed of the airplane in still air. So we got two different trips on this one. We got a trip, we'll just say with the wind, and I'm not spelling with, even though it's not that much more writing, but then you got the other trip, which is against the wind. And if you feel the need to break out into song at this point, that's fine. I'm just not going to do it. So with the wind, right? So they started out right here. It's going to go with the wind. That was the 480 miles. But the distance, by the way, for both trips is the same. It's always going to be 480 miles. All right, so with the wind, okay? So there's two things we're solving for in this one. And again, this may be good, and it is a good time for me to stop and set this up. But maybe you've done that before already in this problem. I need to just define the two variables, right? So the first thing it says that it wants us to do is, I'm going to say x, that's going to be the airplane speed. Some students prefer this. I got to stop talking so I can spell airplane. Sorry about that, airplane speed. Okay, some students prefer the x to be the wind speed. Doesn't matter, okay? And then the y here for me is going to be the wind speed. Some students even say A for airplane speed and then W for wind speed. Doesn't matter, okay? Some people use icons or emojis. I really don't give a crap. But in any case, we got to go with the wind first, which means you would take the airplane speed. Now, since it's going with the wind, we're going to add that speed to the airplane speed. And again, if you're a physics nerd, please don't freak out right now. It's just going to make things more complicated if you want to add more factors in there. Okay, so x plus y equals 400, oh, not 480, but it's 480. That was how many miles? Remember the speed right here for both x and y, that's a rate. And so the 480 miles is miles, but as a rate, it'd be 480 miles in 3 hours. So I'm going to divide that by 3. And then that would give me that equation. Okay, now to set up the second equation, this is against the wind. So you take the airplane speed, and then you would subtract now the wind speed, and then it would be the same distance, 480 miles, but now it's going to be in 4 hours. All right? All right, so from the red equation, right, we got the x plus y. But 480 divided by 3 in my calculator is going to give me 160. So that would be the speed of the airplane with the wind. We had to figure that ourselves because 480 is just a distance, 3 is just the time, 3 hours. We need miles per hour. That's going to give us the speeds there. Then we got the purple equation. Speed of the airplane minus the speed of the wind is going to equal 480 divided by 420. That'd be 120 miles per hour, okay? So this now is our system of equations that we can solve. And as it turns out, the coefficients of y are already set up to eliminate. So when I combine my x's there, I'll get 2 x's. The y's will zero out. And then I add my 2 speeds together, that'd be 280. So double the speed of the airplane is 280. A little bit more space here, dividing both sides by 2. And you see x, the speed of the airplane, would be 140 now miles per hour, mph. Okay. Now, you also have the speed of the wind. You could use either one of the red or purple equations. I'm just going to use red just because it's nice. In fact, after we did the 480 divided by 3, so x is 140 now. But if you add the speed of the wind, you'd get the 160. Just subtract the 140 from both sides. And the y then is going to equal 20 miles per hour. That's the speed of the wind. So that's the boat in orange. And in blue, we have the wind speed. Okay, now there was a different way to solve this, and I think we've gone over it before, but just to make sure, you have the 2 speeds, the speed with the wind and the speed against the wind, the 160 and 120. Let's go and look at those separately, okay? 160, that was the speed with the wind. And then you also had the speed of the wind, or against the wind, which was 120 miles per hour. Now, what you'd look for here is the number that's right in the middle. Right in the middle of 160 and 120, okay? Which, if you look, that number is 140. Now, not only is it 140, that's 140 miles per hour. That'd be the speed of the airplane. The speed of the wind is the difference of these two. So you can see how you can add 20 to that 20 miles per hour to get to 160, or you can take away the 20 miles per hour to get the 120. That tells us that the speed of the wind would have been the 20 right there for both. Okay, so it's kind of an average kind of thing. You could say 160 plus 120 is 280, then divided by 2, here's the 280 by the way, divided by 2 is 140. And that would have given you the speed of the plane. And then the difference between the speed of the plane and these two values, that has to be the speed of the wind in these scenarios, especially when we're not considering any kind of like drag or friction or anything like that. So this one's going to work the same way. I'll do it both ways. Hopefully that'll help, and then you can choose which one you like the best. Now, there's 2 directions right here. You're going upstream. Okay. Upstream. Which upstream is against the current. So that'll be important to remember. Okay, so that means you'd have, I should define my variables, right? So I'm going to say x is the speed of the boat. And then y is the speed of the current. Or the water, whatever. So upstream is where you take the speed of the boat, and you'd have to take away the speed of the current. And it even tells us up here that upstream there is 4 miles per hour, so that'd be 4. Then you got downstream. And downstream, as it turns out, is with the current. So that means you'd have to take the speed of the boat and add the speed of the current, which is showing up here as 8 miles per hour. And again, this one sets up just like it did with the airplane one in the last example, where the y's are already set up. A negative 1y and a positive 1y, they're already set up to eliminate. So when I combine my x's, I got 2 x's. That's 2 boat speeds would be the same as, we zeroed out the y's. 4 plus 8, that'd be 12 miles per hour right there. So with that 12 miles per hour, that's double the boat speed, but we only want one boat speed, so divisible by 2. And x, the boat speed now is 6 miles per hour for the boat. So if the boat's going 6 miles per hour, then what you can do is you take the speed, I'd take the downstream speed, 8, and just subtract the speed of the boat, and you'd have the speed of the current, which is 2. Okay, like this. So either way you want to do it is fine, but remember, you could have taken those two speeds. You had the speed with the current at 8, against the current at 4. What number is right in the middle of those two? Right between 4 and 8, it's 6. So that would have been in the speed of the boat. And once again, you have the current, which would have either added 2 miles per hour upward, or against the current, you would have had to have subtracted 2 miles per hour. Okay, so again, it's an average is 8 plus 4 is 12, divided by 2 is 6. And then the difference is the speed of the current in either direction.